Okay, everybody. Good afternoon to you all. Not good morning. I hope you guys are well. Now, let's go over some details because there's always some details to go over and talk about just to remind people, right? Let's go over the schedule again and notice that today is Tuesday, December 5th. And what are you guys going to see next week? Your final exam, and it's at what time? Not 2:30 a.m. 2:30 what? P.m. Not a.m. but p.m. It's 2:30 to 4:30. So that's our final exam day. Now that means this is our last week, and there's no office hours next final exam week. So the blue week there's no office hours in that week. So we're going to be done, ladies and gentlemen. And anyway, okay, now let's talk more about some things. What do you guys have due next week, the day of your final? Anybody know what is due next week? If I go to the assignment portion, your test 4 is due when? Next week, December 12th at 2:30 p.m. So if you're done today, you can turn it in today. If you're done tomorrow, you can turn it in tomorrow. But the deadline is here, December 12th at 2:30 p.m. Okay? And of course, you submit it in Canvas like you've done your homework. In the assignment portion of Canvas as a batched PDF. Somebody has already submitted it. There's one submission. You go, oh my God, Mr. Judge. And by the way, also what's due is homework number what? 5. I'm sorry, that's the wrong one. So homework 5 is due. And, oh, maybe we don't have that here for you guys yet. So, do we? Homework 5? Where's going on? Okay. Well, I guess I'm going to assign it today. And it'll also be due next week as well. So, we're coming down to the end, okay? So, you guys have any questions on that? Nope. Remember what we were working on last time? We started what? Hypothesis testing about 2 means. So this is the work we were working on last time. Hypothesis testing about 2 means. And I did put, last time in the chat, I did put the link. So there you go, ladies and gentlemen. Wow. Wow. Okay. And I do have those same notes, good afternoon, in my iPad. So we're going to give you guys some more, maybe give you a little warm-up. There we go. Well, that's the notes we went through. How about if we say this? Let's give you another example, because you're going to use, again, 2 sample t-tests here. So let's see. Let's find it. I thought there were some notes on that. All right, maybe not. We'll create them. Okay, so we'll call this hypothesis testing fall. Okay. Good afternoon. So let's give you hypothesis testing about 2 means. So ladies and gentlemen, let's do an example here. We're going to say the mean sleep time for men, okay, I'm going to say is the same as the mean sleep time for women. Okay, again, as claimed by Snodgrass. Okay, now I'm going to give you some sample information. So here's the sample information for the min. I won't write it down. I'll say the mean, the sample mean for min is about 7.2 hours. Sample standard deviation, we'll say, is 1.8 hours. And the sample size was 120. Okay? The sample for the women had a sample mean of, that's the second sample, of let's say 7.5 hours with a standard deviation of 1.2. Now the sample size for the women, we'll say is 150. Use the 5% level of significance to test this claim. So I'll give you guys some time to write this stuff down. We'll go through it together, but it's another 2 hypothesis testing kind of question, okay? There you go. Okay, so, okay, did you guys write this down? So we're going over some more examples of hypothesis testing of 2 what? What are the parameters again? If it says mean, what are they? That's a mean, is that true? So we got mu1, mu2. What's the claim? Have the same sleep. So that's going to be what? Equal. Here's your claim. So when we write this stuff down, what do we know? We put what? Here's what's going on. We have what? Mu1 equals mu2, and then that's the what? That's the claim. So here's our what? Null hypothesis. Here's the alternate hypothesis. And that's going to go where? Do you guys know? That's a null hypothesis. And then mu1 is not mu2. So is everything okay so far, ladies and gentlemen? So far so good? You guys remember that. Now, remember this here. We're going to use the modern method. So 5% level of significance by the modern method, right? Alpha is 5%. We need to check if the p-value is low. And you say, what do you mean low? The p-value needs to be smaller than your what? Level of what? Significance. So last time, and I downloaded the notes. Let's see if you guys can see. Where are we? It's going to be, we're not using the traditional method. We're using the modern method. So that's good. If you want to look at the traditional method, you can. But what are we looking for here? Stat test. This is going to be 2 sample what? Not z-test, but what? T-test. Now you say why, okay? So let's go back to our notes. You're going to use 2 sample t-test. Oh. Now, I know typically you say, but isn't that a large sample? And you go, oh my God, why is it the t-test? Well, because the detail here is you use this when you do not know the true standard deviation values, right? When these 2 values are unknown. And they're unknown, and that's a small technical detail. Now, will you guys have that on your summary sheet? Yes, because I let you guys use a summary sheet, okay? So it's going to be there. I'll provide you the summary sheet for your final. It's the same summary sheet you guys have been using. It has this information. If you want to see it, you go, I want to see that summary sheet, Mr. Judge, because I just don't understand what you're talking about. Well, I did give you guys a summary sheet that you've been using. Bless you, is right here. So let's download it. It's a big file, so it's going to take a while, some time. So time. Yeah. Okay, you guys see this? 2 independent means. What does it say? Stat test 2 sample what? T-test. Okay, you guys okay with that? So you go, oh, wow, that's pretty good. So let's go to the TI now, okay? All right, so in our TI, if we scroll kind of in a bit, we want to do 2 sample t-tests. So we can say what? Stat test 2 sample t-test. What's the first sample mean? 7.2. What's the first standard deviation?
1.8.
Sample size. Second sample mean.
7.5.
I guess I hit something wrong. Sorry. Stat test. Let's go back. 2 sample t-test, number 4. Okay, now we're in the second standard deviation. So that's 1.2. And then the second sample size will be what? 150. Is this a two-tailed test? How do we know it's a two-tailed test? Oops, sorry. Yeah, let's go back here. Right? It's a two-tailed test because of what it always tells you. The inequality here is not equal. Two tails. Okay. Calculate. What do you guys get? What does this say? What's the p-value? Right? Let's go to the nearest thousandths for the p-value. So the p-value is going to be approximately 0.118. And when it's 0.118, is this actually smaller than 5%? Say no. What does that mean? You keep the what? You keep the null. It's when the null is low, lower than the level of significance, then it has to go. But if that's not happening, you keep the null. And so when we keep the null here, say, what does that mean? We're keeping the null. Well, when you keep the null, you're getting rid of the alternate. So what does that mean in this case? Sample supports the claim. It means the means are the same. So it does mean that men and women get the same sleep. Okay, men and women get the same sleep. Your conclusion, the sample supports the claim. There it is. Easy peasy lemon squeezy. You guys like that? Let's give you guys another one. Let's compare men and women here, okay? So men and women get the same sleep. How about this? Huh? So, well, let's see. Who has more friends on social media? Men or women? What do you think? Men and women, who has more friends?
I wouldn't know.
How about if we just conduct a test? We'll say this, right? The mean number of friends men have on social media is less than the mean number of friends for women. As claimed by Snodgrass, okay? Use the 1% level of significance to test this claim when the sample information is below . Okay, so we're going to take again two groups again. The men, let's see, they have a mean number of friends on social media to be maybe, I don't know, 122. Standard deviation will be 21.6, 200 sample size. For women, we're going to say the sample mean for women is 138 with a 36.1 standard deviation, and that sample size is 180. Okay? So take a look at the information, write that stuff down. Okay, you guys okay with that? Let's read this now. What does it say? The mean number of friends that men have, that's the first group. Men is what? Less than the what? Mean number of friends for who? For women. And then that's the claim by who? Good old Snodgrass. All right. Mu1 is less than mu2, and here's your what? Here's your claim. So where does this come from, or where does this go? Is that a null or an alternate? A null or an alternate? Null or an alternate? Where do you guys put that? Good. Why is it an alternate? Because there's no... Yeah, there's no what? Condition of equality. So what's the logical opposite of that statement? Mu1 greater than mu2. What kind of test is this, by the way? Good job. It's left tail. Is that right? We're going to use the modern method. The level of significance is 1%. Right in here. Use the 1% what? Level of significance to test this claim. So we have to check, is P smaller than alpha? Is P less than alpha? And alpha being 1%. So here's the sample information for the first group, sample information for the second group. And then remember, this is what we're using here, okay? But remember, what test do we use? Two sample t-tests. I would even write that down, okay? Because that's kind of important. Stat test. Two sample t-test. Number 4. So what's the first mean? 122. What's the first standard deviation? Is that 21.6? What's the first sample size? 200. Okay, now go to the second group. The mean number of friends is 138. 36.1. Standard deviation. What's the next sample size? Is that 180? What kind of test is this again? Anybody remember? Left tail. That alternate hypothesis is inequality is pointing to the left. Left tail. Hit calculate, and ladies and gentlemen, what's your p-value? Isn't this approximately 0? Okay, is that less than, remember, this is scientific notation. That's e to the -7, so your p-value is approximately 0. Is the p-value low? Is that p-value of 0 less than 1%? Yeah, so the p-value is low. What does that mean about the null? You gotta sing it out loud. The null has to what? Go. When the p-value is low, the null has to go. So you go, oh my God, the null goes. Goodbye, null. And when the null goes, you accept the what? Alternate, and that happens to be what? The claim, ladies and gentlemen. So, you know, the mean number of friends that men have, because they're in the first group, is less than the mean number of friends for for the second group, which is women, we say the sample what? We should say the samples. The samples support the claim. What do you guys think? Easy peasy lemon squeezy? Yeah. Okay. You guys ready for another one?
Sure.
Should you guys try these? The mean what? Oh, let's see. What about, you guys want to compare men and women again? What should we compare? The mean hours, the mean study hours for men is greater than the mean study hours for who? For women, as claimed by who? Snodgrass. Okay. So here's the sample information for the men. Say, guess what? The men study, and this is like maybe in a day, for, I don't know, 2.4 hours. The standard deviation of 0.6 hours, and then the sample size for that first group is 50. And then for the women, you got a sample mean here of maybe 2.8 hours. Sample standard deviation of 1.1 hours. And the sample size is 75. Okay, so we're kind of back to the old format. Use the 5% level of significance to what? Test this what? Claim, okay? So I'm going to have you guys try this out yourself, okay? I'm going to have you guys try it. We're going to give you guys some time. And let's see how it goes, okay? Let's try this out. Okay. So, ladies and gentlemen, let's try this out, okay? What does it say? The mean study hours for men is what? Greater than the what? The mean study hours for what group? Women, as what? Claimed by Snodgrass. So, greater than. So we're going to say what? Mu1 is greater than mu2. And what is this? The claim. Okay, so we're going to set up the hypothesis. And then you guys have to tell me, where do we put this? Is that a null or an alternate? A null or an alternate? A null or an alternate? What do you guys do? Where does that go?
Might be a null.
It's an alternate. Why? Why is it an alternate?
Because there's no equal.
There's no equal. Good job. Good job. You guys okay with that? Okay, so what's the logical opposite now? Mu1 is less than or equal to what? Mu2. Okay. They want us to use what? The 5% level of significance. So alpha is 5%. Is that true? So we're going to use the modern method. And let's see what this is. P is less than alpha. Okay, you guys okay with that? Two sample what? T-test. We're going to enter this information. We're going to get the p-value. We're going to see if it's less than the level of significance. Two sample what? T-test. Stat test. Two sample what? T-test number 4. So, ladies and gentlemen, what's the sample mean? 2.5. Sample standard deviation is 0.6. Sample size is 50. Sample mean will be 2.8. Sample standard deviation is 1.1. What's your sample size? 75. What kind of test is this, ladies and gentlemen? Do you know what kind of test this is? You guys want to tell me? The alternate hypothesis. What does that say? Where is that pointing? This is a right what? Tail test. Because it's pointing to the what? To the right. The alternate hypothesis, okay? So make sure that's pointing to the right, and it is. If I scroll down to calculate, what do we get, ladies and gentlemen? What's that p-value again? What's p? P is approximately what? 0.974. And I'm going to say something about this value, okay? That value is very much not less than the level of significance. It's not less than what? This alpha. So the p-value is high. It's not low. And the p-value, remember, is a probability that the null hypothesis is valid. That's bigger than 95%. It's almost certain to be valid. So we have to keep the null, because it does not satisfy the inequality. So we keep the null. If you keep the null, what does that mean? Keeping the null means the alternate is what? Out. So we hug the null, and you're getting rid of the alternate. What did you happen to get rid of? You just got rid of the what? The claim. So what does that mean? The sample does not support the claim. We got rid of it. So this sample suggests that, ladies and gentlemen, here's your conclusion. Sample does not support the claim. That the mean is less than or equal to mu2. So, yeah, the mean study hours for men is greater than the mean study hours for women. No, that's not the case. There it is. What do you guys think?
Interesting.
Isn't that interesting?
That was pretty interesting.
Should we try one more just for fun?
Yeah.
let's say this to you guys, okay? Who eats more, men or women? I have no idea. Should we say this?
I don't know about that one. I don't know.
The mean calories for who? For men is not the same as the what? Mean calories for who? For women, as claimed by who? Snodgrass. So let's give the men group information, okay? The sample mean for men calories, and this is going to be like calories per day, okay? So let's say men have like about maybe 3,200 calories. Sample standard deviation is 268.4. The sample size we'll say is 250. Now for women, we're going to compare. We're going to say, okay, ladies, sample mean of calories is 3,000, let's say 3,080. Sample standard deviation is 236.8. And the sample size here will be 300, okay? They're going to want you to use the 1% level of significance to test this claim. And of course, we're using the modern method, right? So I'm going to give you guys some time to copy that before we proceed. Okay, let's go through this. You guys okay with that? What does it say? The mean calories for men is not the same as the mean calories for who? Women. And then that's the what? Claim. And how do you write is not the same? Is not equal.
Basically, an alternate.
Where does this go?
Alternate.
Is that a null or an alternate? Null or an alternate?
Alternate.
Good job, because they're not equal. Is that right?
Yeah.
And so remember, that's the claim. We always want to put that word down. Don't forget that. I almost did. And the opposite statement is that the means are equal. Okay. What's alpha again?
1%.
1%. There's your alpha. So we're going to use the modern method, the what? The p-value method, ladies and gentlemen. We're going to check, is p smaller than 1%? Is the p-value less than that 1%? Okay. Two sample what? You know, you can write it down. Let's try this out. Stat test. Two sample t-test. What's the sample mean for men? 3,200 calories. What's the sample standard deviation? 268.4. And that sample size is 250. That's a pretty big sample, by the way. And then what's the sample mean here? 3,080. Standard deviation is 236.8. 300 sample size. What kind of test is this? Isn't that a two-tailed test? Two-tail? Okay, let's hit calculate. What's the p-value? Your p-value is approximately what? 0. And because that's scientific notation, that's 8 to the that's times 8 to the times 10 to the minus 8. You move the decimal 8 spaces to the left. So what that says is this p-value is less than what? That p-value is smaller than the level of significance. 0.000 is less than 1%. What does that mean? If the p-value is low, then null has to go. Goodbye, null. What does that mean?
Claim is true.
That the means are different. The sample supports the claim. Okay, the sample supports the claim. Mu1 is not equal to mu2. Okay? So that means men and women do not eat the same amount of calories per day. That's what they're saying. We eat different calories. What do you guys think? Okay, pretty good. Now, what I want to do today, ladies and gentlemen,